Hello everyone, in this video we will be learning about the concept of test of consistency and solution of linear equation from the chapter Matrices and Determinant. And according to the new syllabus, you only have to learn the matrix method and determinant method you need not learn. But in this video I will be explaining the determinant method because it is much more easier to solve and it is less time consuming. Now let us consider the system of linear equations where a1x plus b1y plus c1z equals d1, a2x plus b2y plus c2z equals d2, a3x plus b3y plus c3z equals d3. Now we'll consider matrix A, which is the coefficient matrix, that is a1, a2, a3, b1, b2, b3, then you have c1, c2, c3. Then you have matrix B, that is d1, d2, d3. Then you have your X matrix, that is the unknown values X, Y, Z. Now we'll consider three more matrices, that is matrix A. If you're wondering what is matrix A means we will be replacing the first column of matrix A by the matrix B, that is d1, d2, d3, b1, b2, b3, then you have c1, c2, c3. Then matrix A2 is will be replacing the second column of A matrix by the matrix B, that is A1, A2, A3. Then you have D1, D2, D3. Then you have C1, C2, C3. Now A3 matrix considering, we will be replacing the third column of A matrix by B, that is A1, A2, A3. Then you have B1, B2, B3. Then you have D1, D2, D3. I hope this point is clear. We have taken matrix A1, that is replacing the first column by the first column of matrix A by the matrix B. Then for A2, replacing the second column by matrix B. Then A3, replacing the third column by matrix B. I hope that point is clear. Now considering homogeneous equation. Homogeneous equation means the matrix B will be equal to 0 and it will be always consistent. Okay. We have two cases. First case 1, when determinant A is not equal to 0. That means it gives unique solution which will be consistent. It will have trivial solution. Trivial solution means the values of x equal to y equal to z equal to 0. That is what it means by trivial solution. Now case 2, when determinant A equals to 0, that is infinitely many solution. Infinitely many solution, and it will be also consistent, always consistent. Now non-homogeneous equation. Non-homogeneous equation means the matrix B will not be equal to 0. That is non-homogeneous equation. Now we will be learning about Cramer's rule or Cramer's rule. Okay. Cramer's rule, we have case 1, that is determinant A not equal to 0. That means it will give unique solution which will be consistent. So x, y, z will have unique values. To find out the value of x, we will be writing determinant A1 divided by determinant A. For y, value of determinant A2 divided by determinant A. Z is determinant A3 divided by determinant A. We have already found out what is determinant A, determinant A1, determinant A2, determinant matrix A1, matrix A2, matrix A3. You need to find the determinant of this, then divide it by determinant A. We will find the values of x, y, z. That is why I mentioned earlier the necessity of finding out matrix A1, A2 and A3. Okay. Now we have case 2. That is determinant A equals 0. Along with that, you have another condition, that is determinant A1 equal to determinant A2 equal to determinant A3 should be equal to 0. In this case, it is infinitely many solution. And it will be consistent. Consistent means it will have a solution. Infinitely many solution means it will have many solutions. Unique solution means it will have only one solution. Now case 3. When determinant A is equal to 0 and determinant A1 or determinant A2 or determinant A3 should not be equal to 0. Any one of this should not be equal to 0. That is a case of no solution. That will be the case of no solution, which is inconsistent. I hope this point is clear. It is what is Cramer's rule. Now we will do some problems, previous year questions, okay? We have the first question. They have given system of equations and it has infinitely many solutions. Now they have asked to find ordered pair lambda and mu. For an infinitely many solution, you know, determinant A should be equal to 0 and determinant A1, A2, A3, all the determinants should be equal to 0. For finding the value of lambda, first we will take the determinant A and we'll find out. We'll equate it with 0, then we'll get the value of lambda. For finding determinant A, we have matrix 1, 2, 3, 4, 3, minus 4, 8, 4, minus lambda. Equating with 0. Okay. Now we'll expand the determinant. 1 into minus 3 lambda. Then you have minus 4 into minus 4 is minus 16, which will become plus 16. Minus 2 minus 4 lambda. You have minus here. Then 8 into minus 4 is minus 32. Minus of minus 32 is plus 32. Then you have plus 3. 4 4s are 16 minus 24. 8 3s are 24 equal to 0. So opening the bracket will have minus 3 lambda plus 16. Minus 2 into minus 4 is plus 8 lambda. Then you have minus 64 plus 3 into minus 8 equals 0. Then you have 8 lambda minus 3 lambda is 5 lambda. Then you have 16 minus 64 is minus 48. Then you have minus 24 equals 0. On solving, you will get 5 lambda minus 72 equals 0. 5 lambda equals 72. Lambda equals 72 by 5. This is the value of lambda we'll get. Now we need to find the value of nu. For that, either A1, A2 or A3, any of the metrics should be, all the metrics should be equal to 0. So here I will be considering metrics, finding the determinant of matrix A3. For that, the first two columns will be same, 1, 4, 8, 2, 3, 4. Then the last column I will be replacing by 3, 4, 9 plus nu. The main reason for finding A3 matrix, determinant of A3 matrix is that we have the lambda here 72 by 5. So when we find A1 matrix or A2 matrix and solve, fraction comes, it will be difficulty for solving. So by replacing the third column, you don't have to solve in the basis of fraction. So it will be much more easier to solve. That is the reason why I'm finding out A3 matrix. Okay. While in the examination, we can solve by different methods, but our main aim should be using the shortest method so that you can find out the answer very quickly without making much mistakes. Now locate it with 0. Expanding the determinant. 1 into 3 into 9 is 27 plus 3 nu minus 16. 4 4s are 16. Then I have minus 2. 4 9s are 36. Then you have plus 4 nu minus 8 4s are 32 plus 3 into 8 4s are 16 minus 8 3s are 24 minus 24 equals 0. So 27 minus 16 will have 11 plus 3 nu. Then 36 minus 32 will have 4. Minus 4, 2 minus 2 into 4 is minus 8. Plus minus 2 into 4 is minus 8 nu. Then you have 3 into minus 8. 16 minus 24 is minus 8. 3 into minus 8 is minus 24 equals 0. That means we have 3 nu minus 8 nu. That is, we'll have 5 nu minus 5 nu. Then you have 8. You have 11 minus 8, that is 3. 3 minus 24 is minus 21 equals 0. Then minus 5 nu equals 21. Nu equals minus 21 by 5. So your ordered pair lambda nu is equal to 72 by 5 minus 21 by 5. Option number 3. I hope this question is clear. Moving on to the next question. Next question, they have given system of linear equations and they are having infinitely many solutions, and they have given another system of equation and they're asking whether that system of equation is having infinitely many solution, unique solution, no solution. Okay. We'll find out. Infinitely many solution means determinant should be equal to 0. First we'll find the value of k. For that we'll be equating the determinant equal to 0. For that we'll be writing the matrix A, that is 1 2 3 1 3 4 k minus 1, 2 equal to 0. Infinitely many solution means determinant A should be equal to 0. We'll open the bracket, we'll expand the determinant, that is 1 into 3 into 2 is 6 minus 4 into minus 1 is minus 4, minus of minus 4 is plus 4. So plus 4 minus 1, and 2 into 2 is 4, 4 minus again 4 minus of minus 3 is plus 3. Then you have plus k, 2 into 4 is 8, 8 minus 9 equals 0. You have 6 plus 4 is 10, then you have minus 1 into 4 plus 3 is 7, minus k equals 0. On solving, you will get 10 minus 7 minus k equals 0. 10 minus 7 is 3 minus k equals 0. This implies k equal to 3. Now we'll substitute this k equal to 3 in this equations. So first equation is k plus 1. K plus 1 is 3 plus 1, that is 4x. Then you have 2k minus 1, that is 3 into 2 is 6, 6 minus 1 is 5. 5y equals 7. Now you have 2k plus 1, that is 2 into 3 is 6, 6 plus 1 is 7x. 7x plus 3 plus 5, k plus 5, right? So it is 3 plus 5, that is 8y equals 10. This is the equation. To check whether this is having infinitely many solution or unique solution, we need to check what is the determinant of this matrix. Okay, so 4, 5, 7, 8. We have to find the determinant. 4 into 8 is 32. 5 into 7 is 35. When you subtract, you will get minus 3, which is not equal to 0. That is meaning unique solution. Okay, that means unique solution, but in the options when you check, there is unique solution satisfying x minus 1 equal to 1, unique solution satisfying x plus 1 equal to 1, x plus y equal to 1. So you need to find out which equation it is satisfying. For that, we'll consider this as equation number 1 and this as equation number 2. When you subtract equation number 2 minus equation number 1, what you're going to get is 7x minus 4x is 3x. 8y minus 5y is plus 3y. 10 minus 7 is 3. When you divide this equation by 3, you will get x plus y equals 1. So this unique solution satisfies this following equation, x plus y equal to 1. So the answer is option number 4. I hope this question is also clear. Moving on to the next question. This question, the system of linear equations is given and it says it has no solution. No solution means determinant A should be equal to 0 and also determinant A1 or determinant A2 or determinant A3 should not be equal to 0. Any one of them should not be equal to 0. For that, first we will find the determinant A. First we will find the value of A by equating to determinant A. It is 3, 5, 2, minus 2, minus 8, 1, 1, 9, 8. We have 3 into minus 8a minus 9. Then you have minus of minus 2, that is plus 2. 5a minus 18 plus 1 into 5 minus of minus 16. A2 is 16. Okay. We have a minus 8 over here. So minus of minus plus 16 equals 0. Open the bracket. 3 into 8 is minus 24a. Then you have minus 27 plus 2 5s are 10. 10a minus 36 plus 21 equals 0. Then you have minus 14a solving. Minus 24a plus 10a is minus 14a. Then you have minus 27 minus 36. We'll get minus 63 plus 21 equals 0. On further solving, minus 14a minus 63 plus 21, right? It's minus 42 equals 0. Minus 14a equals 42. A equals 42 divided by minus 14, which equals minus 3. Okay. A equals minus 3. Now you need to find B for no solution, right? So here I will be finding determinant of A3. Okay. No solution criteria I have already written here. Determinant of A1 or determinant of A2 or determinant of A3 should not be equal to 0. I am taking in this case determinant A3. So first two columns will be same. 3, 5, 2. Then you have minus 2, minus 8, 1. Then you have B, 3 and minus 1. Now expanding the determinant, we'll have 3 into minus 8 into minus 1 is 8. 8 minus 3. Then you have minus or minus plus 2. Then you have minus 5 minus 3 into 2 is 6. Then you have plus B into 5 minus 8 to minus 8 into 2 is minus 16. So minus or minus 16 is plus 16. We get 3 into 5. 8 minus 3 is 5. Plus 2 into minus 11 plus 21b. We get 15 minus 22 plus 21b. That is 15 minus 22 is minus 7 plus 21b. Now we will equate it with 0 just to find out the value of b. Just to check out for what value of b you are going to get determinant A3 is equal to 0. For that we will equate it with 0. So minus 7 plus 21b equals 0. 21b equals 7. b equals 7 by 21, that is equals 1 by 3. If b equals 1 by 3, then determinant A3 will become 0. Our condition is any of these matrices should not be equal to 0. Any of the determinant should not be equal to 0. But if b equals 1 by 3, then A3 will become, determinant A3 will become 0. So what you're going to do is, for determinant A3 not equal to 0, when b is not equal to 1 by 3. In the options, as you can see, we have got the value of a as minus 3. When we check through the options, we have two options where a is equal to minus 3. You have minus 3 over here, b option. C option also you have a equals to minus 3. When you check the value of b, one option you have 1 by 3, another option you have minus 1 by 3. You can't take 1 by 3 because in 1 by 3 means determinant a is going to become 0. So we will be taking the option minus 3 minus 1 by 3 where the value of b equals 1 by 3, because when value of b is equal to minus 1 by 3, it means that it has no solution. When b equals minus 1 by 3, it means no solution. I hope this concept is clear. Once again, I will say, we already found out that when determinant a3 is equal to 0, when b is equal to 1 by 3. So the value of b should not be equal to 1 by 3, so that determinant a will also not be equal to 0. So in the options you can see value of b either minus 1 by 3 or 1 by 3. We will take the option minus 1 by 3, because if we take one option as b when b equals 1 by 3, it means that it will not satisfy this condition. I hope it's clear. So in the next question, they are given the system of linear equations, and it's told that it is inconsistent. Inconsistent means determinant a is equal to 0. Okay. Third case, where inconsistent means no solution. Okay. Now first we'll find the determinant. To find the value of alpha, we'll find the determinant a, and we will equate it with 0. So we have 1, 2, 1, alpha 3 minus 1, then minus alpha 1, 2, equated to 0. So 1 into 3 2s are 6. 6 minus or minus alpha minus or minus 1 is plus 1. Then you have minus 2. Then alpha into 2 is 2 alpha. You have minus. Then you have minus alpha into minus 1 is plus alpha. So minus 2 alpha minus alpha will be plus 1 into alpha minus alpha minus 3 into minus alpha, that will become plus 3 alpha equals 0. We'll have 7 minus 2 alpha plus 4 alpha equals 0. On further solving, 7 plus 2 alpha equals 0. 7 equals minus 2 alpha. Alpha equals minus 7 by 2. The answer is option D. Okay, this is not the answer. Option D is the answer. Okay, I hope this question is also clear. This question is much more simpler, right? Okay. Moving on to the next question. In this question, it's no solution again. No solution means inconsistent. Okay, for that first you need to find, they're asking what's the value of lambda. For finding lambda, you need to find the determinant. You have 2, 3, minus 1, 1, 1, 1. Then you have 1, minus 1. Then you have mod lambda, modulus value of lambda. Okay, equals 0. If you see the modulus, you no need to get worried. It just simply means that lambda has a positive value and a negative value. That is the meaning of having modulus. Okay. Now on solving, 2 into mod lambda minus or minus 1 is plus 1. Then you have 3. Then you have lambda minus 1. Then you have minus 1. Again minus 1, minus 1. Looks confusing, right? Okay. 2 into mod lambda plus 2. Then you have minus 3 mod lambda plus 3. Then you have minus 1 into minus 1 minus 2. On further solving, you will have 2 mod lambda minus 3 mod lambda, that is minus mod lambda plus, then you have this will become plus 2, right? 2 plus 3 plus 2, that is 2 plus 3 plus 2 is 7 equals 0. That means 7 equals mod lambda. So lambda equals plus or minus 7. Okay. We have two values of 7. And the options also two values are given, lambda equal to 7, lambda equal to minus 7. For which value of lambda it will give no solution. We need to check that fact. For that, first we'll find for lambda. When lambda equals to 7, what is the value of determinant that you're gonna get? We'll check first that. Okay. I'll be checking the determinant of A3. Okay. First two columns will be same. 2, 1, 1, 3, 1, minus 1. Then you have minus 2, 4. Here it is 4 lambda minus 4. That lambda value I have taken 7. When lambda equals 7, that is what you have taken here. That is 28 minus 4, 24. Okay. We have 2 into 24. Minus of minus 4 is plus 4. Then you have minus 3. 24 minus 4. Then you have minus 2. That is minus 1. Minus 1. So 2 into 24 plus 4 is 28. Then you have minus 3 into 24 minus 4 is 20. Then 2 into minus 2. 56. 2 into 28 is 56 minus 60 minus 4. Sorry, plus 4. We'll get 56 minus 56 equals 0. Determinant of A3 will become 0 when lambda equals 7. For no solution, our condition is that determinant of A1 or determinant of A2 or determinant of A3 should not be equal to 0. Here A3 is equal to 0. Therefore, for lambda equal to 7, it is not no solution. No solution is not possible. So lambda equal to minus, since lambda equal to 7 is not no solution, so lambda equal to 7 should be no solution case. I hope it's clear. I'll tell you once again. Here, when you solve for determinant, you will get the value as 0. Determinant A3 equal to 0. So when determinant A3 equal to 0, when lambda is equal to 7. So lambda, when it is equal to 7, our condition for no solution is that determinant A1 or determinant A2 or determinant A3 should not be equal to 0. But here A3 is determinant is equal to 0. In that case, it is not a no solution when lambda equal to 7. So no solution means lambda equal to minus 7 is the case. This is lambda equal to 7 is the case for infinitely many solutions. For infinitely many solution also, you know, determinant is A equal to 0. For determinant A equal to 0 means either it can be no solution or it can be infinitely many solution. When determinant A3 is also 0, that means it is infinitely many solution, this lambda equal to 7. I hope it's clear. Okay. Moving, and this is the final question of our video. So in this question, given system of linear equations for infinitely many solutions, and they have asked to find the value of dou and k. You need to add the values of dou and k. For finding dou, you know the step, that is determinant A should be equal to 0. And for infinite many solution, either determinant A1 equal to 0, determinant A2 equal to 0, or determinant A3 equal to 0. All of them should be equal to 0 for infinitely many solution. So let us find the dou's value first by finding the equating with the determinant A equal to 0. That is 2, 1, 1, 1 minus 3, 4 minus 1, 2, dou equals 0. Then you have 2 into minus 3 dou minus 4 2s are 8 minus 1. Then you have dou minus 2. Then you have minus 1, 4 minus of minus 3 is plus 3 equals 0. We will get minus 6 dou minus 16. Then you have minus 2 plus 2. Then you have minus 7 equals 0. Minus 6 dou and 7 dou, you will get 7 dou. Then you have minus 16 plus 2 minus 7. On solving, minus 16 minus 7 is minus 23. Minus 23 plus 2 is minus 23 plus 2. That is minus 21. So we'll get minus 7 dou minus 21 equals 0. So minus 7 dou equals 21. Dou equals minus 3. 21 divided by minus 7 is minus 3. We want dou equals minus 3. Now you need to find the value of, what to say, k. So for finding k, either find determinant A1 as 0 equated with 0, determinant A2 equated with 0, or determinant A3 equated with 0. I'm finding out determinant A3. For that, 2, 1, 1, first two columns same. Minus 1, minus 3, plus 1, minus 3, 4. Then you have 7, 1, k. Equating with 0. 2 into minus 3k minus 4. Then you have minus 1, k minus 1. Then you have plus 7. That is 4 minus 1 minus 3 plus 3 equals 0. Now on solving, 2 into minus 3 is minus 6k. Then you have minus 8 minus k plus 1. Then I have 7 into 4 plus 3 7. 7 sevens are 49. So minus 6k and minus k is minus 7k. The minus 8 and 1 is minus 7 plus 49 equals 0. Then have minus 7k. 49 minus 7 is 42, which will implies minus 7k. I'm sorry, it's plus 42. Okay, 7k equals 42. K equals 42 by 7 is equals 6. They've asked what is dou plus k. Value of dou plus k. Value of dou is minus 3 plus 6. We'll get the answer as 3. So the option B, this is the answer. So this is the end of the video. I hope this video was informative. I hope whatever I have explained, and I hope you understood everything. And you have any suggestions or feedbacks, you may feel free to write down in the comment box. And see you guys in the next video. Till then, bye.